All right, hi everyone. This is lecture video part two of the unit one, part one, rate of reactions. Textbook that you can refer to is chapter 6.4, rate of chemical reactions. Information can be found in that part, in the section. All right, let's look at firstly the big idea. Big idea is not, I guess, something that you need to copy down, but you should know why we are doing it. Okay, substances change, and the new substances are produced by energy transfer. Now, energy transfer is the biggest part, I suppose, for rate of chemical reactions, because if you look at the next bit, which is what affects the rate of reaction and why. You will be hopefully able to do this prac at home, or at least watch my video and write investigation methods for that. But you'll be saying something, you'll be answering, and you'll be knowing something about rates of chemical reaction can be affected by certain things, and you do that through experiment. Before we jump into rates of chemical reaction stuff, I need to draw attention to the particle theory of matter. It's also known as kinetic theory of matter. You would have done this back in year 8. There's a video link in the title there, the particle theory of matter. It's a bit kiddie-ish sort of video, but gets the point. The point that I would like you to take note of is kind of summarized into 5 points there. Okay. Firstly, all matter is made up of tiny particles which are too small to see. There are species between particles. There are attractive forces between particles. The weaker the forces are, the further apart the particles are. The particles are always moving. At high temperature, or if they get some sort of energy, the particles move faster than they do at low temperature. Now, I hope this is not a new idea for you, because it's supposedly done 2 years ago at least. The reason why I needed to cover this is that the particle theory of matter, okay, the assumed knowledge here, is something that you can use to help explain what happened in your practical work that you do. Okay, you are supposed to do. So in prax, you would observe by you changing a factor or increasing, say, concentration or temperature of things, you would observe that reaction rate also goes up. For you to explain why that happens, you can refer to the particle theory of matter, saying things like particle theory of matter. The particle theory of matter states that at the high temperature, particles movement becomes faster. Therefore, blah blah blah. The more successful collision occurs, or the rate of it breaking apart is faster. Hence, the rate of reaction appear to be much faster. I hope you can do that. I hope you can refer to the particle theory matter to explain what you observed. So yeah, you don't have to copy everything from this slide to your book, but what I highly recommend you to do is to take note the fact that this stuff on this slide can be used as the explanation of the results that you will write in your investigation practical report, which you will submit, which goes to your grade. All right. Chemical reactions, let's focus on that now. The idea that you should write here is the chemical reactions happen at various rate, different speed. Now, there's a chart here from slow to fast. Okay, I've got slow to fast written on here as well. Pause the video and try filling that up. Try coming up with your own idea of slow or fast reaction. I would say slow one takes years, fast one takes second or even less. All right, pause the video now and try filling this up. All right, start the video again. Let's think about a few things that would happen over a few years. To me, so one of the slowest reactions that I can think about is decomposition. Hope you can read that. Decomposition, like dead body, human body in a coffin, which is, put down into the ground, and then how long does it take for them to become, part of soil, part of dust? It would take years. So decomposition would be, in this case, in my case, it's one of the slowest things that you can think about. That takes years. Yeah. Next one, a bit faster than years. So a reaction that takes maybe a couple of weeks. I'm thinking about cars rusting. Usually takes a few weeks, or it could be a few days, depending on the situation. Like if it's around the sea, usually it goes much faster. Something that takes days instead of weeks. What can you think about? Or maybe just one day, or something that happens in your stomach. Did you come up with an idea of digestion? As a reaction? It is a reaction. Something that you eat looks totally different, smells different when it comes out, don't they? Yeah. So digestion is a chemical reaction and takes about a day. All right. Something that's much faster than digestion. Well, how about preparing food, or cooking? Could it be a few hours? Could it be 40 minutes? Could it be 10 minutes, 15 minutes if you're Jamie Oliver? That would be something fairly fast. Something that takes maybe a few minutes instead of hours. What can you think about? I don't know. This one's the hardest one. I can pick many because I do reactions all the time. I know that if I put magnesium or zinc into acid, some sort of acid, it takes a few minutes to dissolve. So I'm just going to write that. Mg for magnesium / Zn for zinc in acid. So dissolving them takes about a minute or minutes, depending on how concentrated the acid is or how big those pieces are. Something that takes maybe seconds. I'm thinking about fireworks or what happens in car engines. So it's called combustion. Now, which could be said as, well, some type of burning. If it's just normal, burning wood, burning coal, burning charcoal, it takes maybe a bit more than a second. It might take a few minutes. So burning wood might be a bit slower there. But combustion, I'm referring to explosion and say fireworks, or how pistons in the engines work. So I'm just putting explosion here. Okay, so because some combustions can take a few minutes. Now, add these to your list as well. There you go. And complete the list, or just make it more. All right, a break from my own talking. I would like you to have a look at how to speed up chemical reactions, and in bracket, and get a date video, which is a TED Ed video, which you can find on YouTube, or click on the link that's in my lecture note that you're looking at here. Okay. Then try finding out different ways, different factors that affect the reaction rate, which goes there. Okay, So watch that, well, pause this video and watch that and then come back to it. Now once you're back, factors which affect reaction rates. I hope you got a few ideas. Temperature, you can change the speed of the particle's movement. Concentration, how many things are present, how pressurized the vessels are. Surface area, if chemicals are clumped up, then something in the middle won't be able to react. So separate them. Presence of catalyst. If there was some sort of catalyst available, how long would it take for, say, bread to be made? It might be a bit, or you might not be able to get the same fluffiness if you didn't have yeast, which has got enzyme in it, which is a catalyst. If you didn't pick it up, let's just add a note for catalyst. So after writing presence of catalyst, in bracket, or write a note saying that catalysts are substances that can speed up the reaction, but not part of the reaction. I'll repeat again. Catalysts are substances that speeds up the reaction, but do not take part in reaction. So in the video that you watch, in the video of how to speed up a chemical reaction and get the date, this older lady, matchmaker person, was featured. So she is not part of the reaction, as in she does not be part of the date couples. Okay, she's just a matchmaker, and once that person grabs the reactants together, form product, off they go, pushes off, and then grab other sets of reactants, and more products are formed. So that's what catalysts do. All right, recap question. This is the end of this video, guys. What is rate of reaction? Have a think. Try answering that. Write your own question. Answer for that. You can just use different words like speed of blah, or I think speed is okay. How can the rate of reaction be measured? I want you to think about the physical method that you can use to measure things, okay? If you go back to the list of chemical reactions we just made, what sort of unit was this in, gang? How long decomposition takes? How long rusting takes? How long cooking takes? How long combustion takes? What unit are we talking about here? How would you measure them in the sense that you can maybe achieve in a chemistry lab? Okay. Time is firstly the thing. You could also look at how things are being consumed, or how things getting generated by measuring amount of gas, for example, or by measuring the weight loss if things are getting lost. Okay, you could also look at the change in pH value or amount of light in a given amount of time, but time is definitely one factor. Okay, so it says 1 and 2, but there could be more than 2. Third recap question, how does the rate of reaction change over time? Well, you can look at the graphs later on and try answering that. At the moment, I would like you to try doing these tasks that's written there. So skim through module 6.4, have a read and get more ideas about how you can change rate of reaction, or what the rate of reaction is about, which might allow you to answer the first recap question, which is page 258 to page 262 on the textbook. Also, you can try doing the review questions 1 to 16. Something that we can maybe have a look at answer later on, especially in a Zoom meeting or online meeting, or maybe when you are back in class. All right, so have a go at those, please. I'll see you in the next video. See you then.